Managing fluid retention is essential for health. In this video, we're going to discuss how your body manages fluids and how that relates to dosha. On the deepest levels, our constitution, your body type, is how your body manages fluids, heat, and stress. This is almost so basic to our physiology that it's essential for anyone who wants to practice Ayurveda and master Ayurveda that they master the endocrine system, right? The endocrine system is where we manage fluid retention, and we all know that fluid doesn't just mean water; it also means nourishing fluids. It means our ability to build tissues and restore tissues, right? That's all under the heading of fluids. And then we have heat or metabolism, how we're using the energy that we've acquired. And then finally, stress, how we respond to threats. All of those are so basic to our constitution, you can almost say they make our constitution. As Ayurveda practitioners, we want to master assessment of problems with fluid, heat, and stress management, as well as how to correct it. So we do need to be masters of the endocrine system. In the previous video, we discussed how the adrenals and how the adrenals regulate stress, and we discussed how different doshas might respond to those stressors. We discussed how the amygdala perceives stress, the hypothalamus then releases hormones that stimulate the pituitary, and the pituitary releases hormones that stimulate the adrenals to produce those stress hormones. Now, and then we're gonna switch to fluid retention. So where we were talking about glucocorticoids or sterol in the previous video, now in this video we're going to talk about mineralocorticoids, and these are the ones that manage fluids and blood pressure. So both of them are corticoids. They're both coming from the adrenal cortex. So what is this system that manages fluids in our body? It's called the Renin Angiotensin Aldosterone System, or RAAS. Sounds like a mouthful. Sounds really difficult to understand, right? Well, that's only because it's in Latin and Greek. If we translate these terms, we'll see it's really simple. It loosely translates to the kidney vasoconstricting aldosterone system, right? So kidney vasoconstricting. How do we get to that translation? Well, renes means kidney in Latin. So renin is basically relating to the kidney. Renin is actually an enzyme that stimulates angiotensin. What is angiotensin? Angio means blood vessel. Tensin means tense. So we're tensing up the blood vessel. In other words, a vasoconstrictor. And then aldosterone is well, I wish the explanation would make that one easier to remember, but I'll break it down anyway. Aldosterone is basically formed from two words, aldehyde and sterol. An aldehyde is a dehydrated alcohol, but the person who discovered that came from a language where they would put the adjective after the noun instead of before, so they called it alcohol dehydrated. But we say dehydrated alcohol in English. So we would have called it a dihydral, but they called it an aldehyde, right? So anyway, if that helps you remember, great. Sterol just refers to steroidal action. So maybe the thing to remember there is it's just a steroid, and there's a steroid in the word. So it's the kidney vasoconstricting steroidal system. If that helps you, great. Otherwise, let's move on. So and discuss it, and then we will talk about an herb that can help manage this system. All right, renin is an enzyme, and it's released when the kidneys sense low blood pressure, and it converts this inactive form of angiotensin to the active form, angiotensin 1. And then that angiotensin 1 travels around, goes to the lungs and several other tissues where ACE converts it to angiotensin 2. And that ACE isn't listed here, it just says converting enzyme, but the enzyme is ACE. Let's find out what ACE stands for. ACE stands for angiotensin converting enzyme. Wow, not that mysterious, right? So we get an angiotensin converting enzyme in the lungs that converts angiotensin 1 to angiotensin 2. Now, angiotensin 2 is the actual vasoconstricting chemical. So we've gone through angiotensinogen, which is the inactive, to this sort of intermediate angiotensin 1, and then angiotensin 2 is the active one. And it was converted to the active one by angiotensin converting enzyme, ACE, or ACE. You've heard of ACE inhibitor, right? We'll talk about that in just a minute. ACE inhibitors are a kind of blood pressure medication. All right, so we see that angiotensin 2 is going to constrict the blood vessels and then stimulate the adrenals to produce aldosterone, this dehydrated alcohol steroid, right? And that dehydrated alcohol steroid, or aldosterone, is going to encourage sodium reabsorption by the kidney. Well, if you tense up blood vessels and you encourage water retention, you're going to raise blood pressure, right? So what happens when you squeeze blood vessels? It's like squeezing a balloon. The pressure builds. And if you increase the amount of air in the balloon, the pressure is going to build as well. Well, in this case, the balloon is your blood vessels, right? It's an oddly shaped balloon, but it's nevertheless, if you looked at it correctly, you would see it's kind of like a balloon. And if you put more water into the blood vessels, it's going to increase the pressure. And if you squeeze the blood vessels, it's going to increase the pressure. So altogether, this angiotensin 2 increases blood pressure, right? This is important stuff for you to know because we need to know how to affect this, right? And immediately we see a bunch of intervention points. We see that we could try to block renin or block renin receptors or something, this is, or we're going to try to block ACE, an ACE inhibitor, so that this enzyme can't convert it to the form number 2. Or we're going to increase our intake of sodium. All of that is different ways to either lower or increase blood pressure. Oh yeah, so since if we inhibit renin or inhibit ACE or reduce sodium, all of that is going to prevent this blood pressure raising action. But if we wanted to go the other direction, we could try to stimulate renin, stimulate aldosterone, or eat more salt, and that would encourage blood pressure to go up. Some people have low blood pressure, some people have high blood pressure, right? So that's the long and short of it. We see our intervention points once we know the physiology. That's why physiology is so important, right? Okay, so let's do a little summary. Kidneys sense low blood pressure. Then they put out the renin, and renin causes this whole cascade that eventually leads to water retention and constriction of blood vessels. That creates high blood pressure. Also, by the way, potassium is excreted. So we're losing potassium, gaining sodium. How does this relate to dosha? Vata people lose too much fluids. So we want to encourage renin, ACE, and aldosterone, and salt in Vata. But Kapha retains too much fluids. So for them, we want to find a way to block renin, ACE, aldosterone, and to lower sodium, right? That's going to help Kapha reduce blood pressure and help Vata increase moisture. Help Kapha lose moisture, help Vata increase moisture. All right, so there's your ACE inhibitors, a whole class of blood pressure regulating. And then there's your angiotensin receptor blockers that prevent your blood vessels from constricting. All right, good. We've got our overview of the kidney vasoconstricting steroidal system, also called the renin angiotensin aldosterone system, or the um, dehydrated alcohol steroid, right? And that's abbreviated RAAS. So know this, and then let's talk about an herb, licorice, and how it affects this system.